Hi, my name is Matthew Henderson. I'm a program manager on the Azure Functions team. Today, we're going to talk a little bit about Azure Functions under the hood. And what I mean by that is we'll go through the basics of how Azure Functions works, how you can use it, but then really focus on, what are the components that make up Azure Functions and what sort of features that enable for you as a developer. We'll take a look at some of these advanced features in the context of a couple different scenarios where you can start using Azure Functions just like you would be working with any other service in Azure. So I'm assuming a little bit of knowledge about Azure Functions. For a deeper introduction, I refer you to the Day 2 keynote or to my colleague Chris Anderson's talk titled Introducing Azure Functions. But we'll do a little bit of an intro here. So Azure Functions is a way to get the most benefit for the least amount of code. Rather than writing an entire site in order to handle one particular task, you can focus just on the piece of business logic that you care about. We'll take care of the rest. If you think about a function that you might write in any programming language, you typically have a set of parameters that go into that function, your inputs, as well as a return type or an output. Those are just, for functions, are Azure services or third-party services that you can just configure. You don't have to worry about any extra parsing logic or anything like that. And also similar to a normal function, you would have it invoked at various points in your program or perhaps on particular events. In functions, you can specify that an input is a trigger. And when a trigger is invoked, we'll wake up your code, run it through, and then tear down all the resources that were required. Never did you have to specify what actually was running your function. That's all taken care of behind the scenes as part of our dynamic compute layer. And what's really nice about that is when your function is done, we take everything back down to zero. So you don't have a standing commitment of resources for running your function. Your function also has a function app associated with it. And all a function app is a container. It's a way of keeping all of the configuration and code around your functions together. If you have multiple functions within a function app, they're capable of sharing things like connection strings to various databases and things like that. And of course, they can also share code. So it's a nice way if you have functions that have something in common for you to organize them in a logical fashion. And it turns out that that function app concept is very important to how functions works. And the reason for that is that Azure Functions is actually part of Azure App Service. So it's running on the same layer that's helping you build web apps, mobile apps, API apps, and logic apps. For those of you who aren't familiar with Azure App Service, it's our platform as a service offering that's really kind of focused on these web, mobile, and API scenarios. We let you bring your own code for whatever site you're building, and we take care of all of the underlying frameworks, taking care of the actual infrastructure that runs your site, and we provide a lot of value-added features that make it easy for you to get started, develop, and manage your code. Azure Functions actually is an evolution of something we've had as part of App Service for a while now, which is Azure Web Jobs. Web Jobs was just a way for you to run certain types of processes. They could be long-running processes, or they could be triggered. And those were baked into the platform for a long time, but with Azure Functions, we're bringing them to the forefront and adding a whole bunch of new capabilities. Now, when I speak to the features that Azure App Service gives you, it's quite a long list. In fact, this isn't the entire enumeration here. But it does give you an idea of all of the features that Functions gets to inherit from. So things like signing in with federated identity providers, or as we'll see later, remote debugging. These are all capabilities that we get to add. Now, I mentioned earlier there was this dynamic compute layer. If you choose, you can also run your function as part of a classic dedicated app service plan, just like you would run a web app or a mobile app today. If you go down that route, you actually have a bit more of a complete list. In the dynamic case, we can't do certain features such as pin and SSL cert. So you'll see that the list is slightly reduced. However, we'll be working to fill in gaps where we can, and this is a great basis for starting to work with functions. You get a lot of great features for free. So let's go ahead and see how we might actually start using those in action. So consider this scenario. I have a web app, and it hasn't been behaving so well recently. It's been returning a lot of 500 errors. And we think we've got a patch in place, but we want to keep an eye on the site. So In that case, we want to know when things start to go bad again. In particular, I want to receive a notification on my phone. So how would we go about architecting this solution? Well, first, we can leverage the Azure Alerts infrastructure to know when the site is actually starting to behave badly. So we can configure the rules for, within a certain time span, however many 500s would actually trigger an alert. So that's great. And on the mobile side, we can leverage app service mobile apps. And this makes it easy for us to expose data down to the client. So, for example, the entire list of previous incidents. And it also integrates with Azure Notification Hubs, which is our push notifications infrastructure. And that makes it easy to actually have the notification appear on the device. But the question then is, how do I connect these two components? And we're going to do that with Azure Functions. So I'll define a function that takes a webhook trigger. So I'll have the Azure Alert actually fire a webhook. And if you're not familiar with webhooks, it's just a way of passing data from one system to another. We'll actually process that data to craft our message and then submit it to the mobile app. It'll get added to the database of issues that we've found, and we'll send a notification as that data is inserted. So let's see how we go about actually building this out. Okay, so here we are in the Functions portal. I'm looking at my function app that I've already created, and we're going to go into Function App Settings. And you can see here we have several features enabled. And if I choose to go into App Service Settings, I can actually treat my function just like I would any other app service instance. So you see everything kind of operating the same. Now, we have several of these features actually brought up to the forefront just because we think these are probably going to be the things you'll be using the most. In fact, today I'm going to actually set up my deployment using GitHub. So we'll be editing all of our code locally and then pushing it up into the cloud. So we'll go into Setup. I'm going to choose GitHub. And I've already associated my GitHub account with Azure, but if you haven't done that before, it'll just prompt you to sign in here. We'll go ahead and choose our Site Monitor project, and we'll be working out of the dev branch today. So this will take a moment to actually set up the deployment source and then perform the first sync. Once that's done, we'll actually want to look at our function again. So we can see that our function has deployed, and if I click in, you'll see that a large portion of the portal is actually read-only. And the reason for that is we don't want you editing your code in the portal only to have it stomped over by later GitHub deployment. But I can still do a lot of useful things such as view the streaming logs, etc. Go ahead and just make sure that we're downstream logs. And so we'll actually go over to our web app. And under Tools, there's an option titled Alerts. We'll go in there and create our Azure Alert. So I'm going to choose, instead of the server farm, that's just the hosting plan that runs my site, I'll choose the site itself, and we'll give it a name, Unhealthy. We're actually looking for HTTP server errors in this case, because the site has been behaving poorly. And we're going to look for, say, 5 events within a 5-minute window. That happens to be the smallest available. And if you scroll down, you'll actually see this webhook offering. We'll go ahead and paste in our function URL and click OK. And this will create the alert. Now, because we're actually going to be working with, because this takes a 5-minute window potentially, we'll actually be doing things via an HTTP client just to speed things up. I'll head back over just because I want to make sure I have those streaming logs open. Scroll down. Great. So now I can use a REST client and actually, so we'll actually use Postman. It's just a simple HTTP client. And I'll go ahead and paste in my URL for this function. And the body here is just what an Azure Alert would look like. So it has some information about the actual event itself and the site that I'm working with. So we'll go ahead and send that. And what we should see is we get a push notification on this device. So we know that something's gone wrong with our site. So let's actually take a look at how that's being put together. So here's my function, and I'm going to actually open my Site Monitor folder. When you grab a function app and set it up in a repo, each function gets its own folder, and within that you'll have a couple of different files. The sample.dat is used for the test client that's actually available in the portal. The main thing we're going to care about actually is the run.csx. That's because I'm using C#. So this is the C# scripting format. So if we take a look at this file, we'll see that we actually include json.net by default, just to make it a little bit easier to work with webhooks. And to reference that, I just use this #r syntax. Of course, you still need all of your using statements in typical C# form. And then we can take a look at our function itself. So you'll see that my function actually has some parameters, an HTTP request message, and that represents my webhook, as well as a to-do item, and that's actually referring to the mobile app table endpoint. In fact, I have a type down below called to-do item, and I'm just using to-do item as kind of a placeholder for that messaging object that we're putting in. You can specify that your outputs are either through the return type or as out parameters. If you have multiple output bindings, then you'll want to use out parameters. So the names of these parameters come from our function.json. And function.json just defines all of the integrations that you have for your function. So we can see that the name of the request object was rec, and it's being treated as an HTTP trigger for a webhook. Similarly, I'm using EasyTable, that's the tables component for mobile apps, and its name is to-do item, and it's an output parameter. This is where you configure the settings that make up these integrations. And for secrets, we actually pull those in from application settings, so that way you're not checking them into your repo. Let's actually go ahead and change this a little bit so that we're actually using the data that we are pulling in from the webhook. So I now have a nice little format string that'll tell me what time we got this alert and some of the details of the event itself. Go ahead and commit that up, and we'll just And so we'll push this up, and if we take a look at our streaming logs, we'll actually see some of the logs from the function invocation before. But as soon as the code actually gets deployed from GitHub, we'll start to see our code get compiled, and then that we're ready with the new version. So there we see it's already started compiling because it saw a change in the files, and the compilation succeeded. So great. Now, if we go back to Postman and send the same message again, we'll see that we have a nicely formatted push notification. So that's perfect. But that timestamp is a little bit problematic. I don't really like the way it looks in my notification. So let's actually change that. And to do that, I actually want to use a NuGet package that I'm aware of called Humanizer. So Humanizer actually has a couple of dependencies on system libraries, which we can reference as well. So we'll go ahead and just add those. Oops. And then I actually want to change the data that I'm getting. So we'll take our alert and we'll go ahead and parse the timestamp out of it and then run humanize. And that's just the main method in terms of how Humanizer works. It'll give us a nicely formatted string that we can use instead of the raw timestamp. So you'll notice that I'm not actually referencing the Humanizer NuGet package here, and that's actually going to cause a compiler error. So let's take a look at what happens when we get an error. We'll go ahead and push that code back up. And we should see in the console that it attempts to do the compilation, but we get a standard .NET error, just like this. So the type or namespace could not be resolved. So compilation failed. My function, still has the previous version to work with, but we do want to fix that. So how can we reference a NuGet package here? To do that, we actually use our project.json. So I'll go ahead and reference the package, specifically version 201, and we'll go ahead and push that up. And what we should see now is when the code attempts to compile, it'll first run a NuGet package restore. So we see that it's starting the restore, and then it should pull in all the dependencies related to that package, and we'll see those appear momentarily. And then after that's after the NuGet package restore is resolved, then we'll run the compilation again, and everything should work. Perfect, so compilation succeeded. Now, if we run once more, we should see that the notification has a slightly different format for the timecode. So great, we were actually able to take a package that we would use in some of our other projects and use it as part of Azure Functions. So we have a function that's pretty much doing everything that we wanted it to, but we also want to make sure that we can debug it if something starts going wrong there. So let's take a look at one of my favorite features in App Service, which is remote debugging. I'm in Visual Studio now, and we're looking at the Cloud Explorer. I can go in and enumerate my App Service instances. They all show up under Web Apps. And we should see my function app listed here. So you can find my function app and expand that. And then let's take a look at the files that are actually on disk. You'll see that in addition to the project.json that we edited earlier, we have a generated project.lock.json. And that's just a part of our processing your dependencies. But what we're interested in here is taking a look at the run.csx. I'm actually going to open the remote file. And we can see all the changes that we've made appear here as well. So what I'm going to do now is attach the debugger. And this is going to actually communicate with the Azure service, make sure that the debugging process starts up, negotiate the ports, and get everything ready so that we can download the symbols and have our local session actually set breakpoints and allow us to step through the code that's running in the cloud. So this will take just a few moments just to get everything wired up. And so when the debugger actually finishes with the attaching, it'll launch the site root, which we don't need right now. And we should see that it's loading all the symbols. And very shortly, we'll have our full debug session ready to go. Okay, so it looks like we're ready. Let's go ahead and set a breakpoint. Okay, so our breakpoint is set. And now, if we go and run our function, we'll see that the breakpoint gets tripped. So we've been able to debug remotely in the cloud, and we can start seeing some of the data that we're getting and figure out what's going on with our function if things start to go badly. Right, so we've now just seen how you can actually really use functions to get quite a lot done without having to write a whole lot of code. This is really the beautiful thing about Azure Functions. And we were able to leverage multiple features of Azure App Service in order to make it happen. So we saw that we were doing the continuous integration because I was deploying my code from GitHub. We were able to actually add NuGet packages to our functions, and we were able to remote debug. These kinds of features make it very easy for you to develop in whatever style you choose. Functions is very good for adding to existing projects, building entire new projects with. You can really take it in any direction and however works best for your team. So there's plenty of other great resources for learning about Azure Functions. There are several great talks here at Build, and of course you can check out functions.azure.com to try things out for yourself. We also have pretty much most of the product is available open source on GitHub, so definitely go check that out, and we really hope you try Functions and enjoy it. Thanks very much.